Hi guys, my name is Vaishnavi and I'm from EC department. We all know nowadays in the world, almost everywhere the uses of sensors got increased. Almost in every field, you can see in the robots and light sensors, soil sensors, ultrasonic sensors, rain gauge, etc. There are a lot of sensors in our daily lives. So I'm gonna tell you about LDR sensor. I choose this sensor to explain now. LDR sensor means light sensor, light dependent resistor, which depends on light. So I'm gonna tell you about this now, a brief explanation, the construction of the sensor, the working principle, and the applications, characteristics like that. So here we go. I prepared a PPT to this sensor. As you can see in the picture, LDR sensor, it's very small in size. And next thing is the content. Now in this video I'm gonna tell you these contents: introduction about the sensor, working principle, characteristics, and this LDR sensor is also called as photocell, which is different from photodiodes and phototransistors. So I'm going to tell what's the difference between photocell and these transistors and photodiodes. And then next, there are also types of LDR sensor. I'll explain them, and then construction of the sensor and applications. Now moving to the introduction of the sensor. Yeah, here we go guys. LDR means light dependent resistor, which is also called photoresistor. LDR is a device whose resistivity is a function of incident electromagnetic radiation, or simply light. This is also called as light sensitive devices. Sensitivity means light sensitive means which reacts easily to the light, as fast as it can. That is called sensitive, which reacts to the substance easily. So it is light sensitive reactor. As long as the light falls on the device, it will sense it and indicate us. This photoresistors are also called as photoconductors, photoconductor cells, and simply photocells. As before I told you, these are also called as photocells, which are different from photodiodes and phototransistors. And these are made up of semiconductors which are having high resistance. This LDR sensor is made up of indicates in different symbols. So here I mentioned a symbol. You can see in the screen. On the screen, there is a symbol of a sensor. This is the most commonly used symbol, and you can see the arrow marks in the picture, and those arrow marks indicates the light falling on the device. It's just a simple indication of the symbol. Next, we'll discuss about working principle of the device. You already know that every device works on a particular principle. Like example, transformer, which works on the principle of mutual inductance, as well as this LDR sensor also works on a principle that is called as photoconductivity. Now let's see what is photoconductivity. Photoconductivity, it is an optical phenomenon in which the material's conductivity reduced when the light falls on the you put a sensor to an object, right? And we are going to check the light sensitivity to that object. So when the object is observed, when the object observes light, that then the material's conductivity decreases. That is an optical phenomenon, which is photoconductivity. So brief definition is I mentioned on the screen. It is an optical phenomenon in which the material's conductivity is reduced when the light is observed by the material, which means when the light falls on the object, that means the photons. You can see the screen. I mentioned picture. I'll explain about it now. When the light falls on the object, then the photons on the object fall on the when the photons fall on the device, the electrons and the valence band of the semiconductor material are excited. See the valence bond and conduction band on the screen. The electrons on the valence bond gets excited on the semiconductor material to the conduction band. These photons are incident, should have energy. These photons in the incident light, the light which falls on the object, should have energy greater than the band gap between the semiconductor material to make the electron jump from the valence band to conduction band. Hence, when the light having enough energy traces on the device, more and more electrons are excited to the conduction band, which results for more number of carrier charges. More number of carrier charges means more energy, so that the light observed can be detected easily. More energy means more heat means more current. The result of all this process, the excitation from valence band to conduction band of the electrons, and it results in more number of carrier charges. So the result of this process is more and more current starts flowing through the device. Then the circuit is closed. Then if the circuit is closed, hence it is said that the resistance of the device has been decreased. You all know, according to Ohm's law, current is indirectly proportional to resistance. More current plus resistance, less resistance, more current. So due to more current, the resistance is decreased. This is the most common working principle of LDR. So did you understand the photoconductivity now? Fine. Next we go to the characteristics of LDR. Here we go. As I told earlier, LDR is light dependent device whose resistance is decreased when the light falls on it, and that is increased in the dark when we put the sensor in the dark. This is called dark resistance. You can see the definition on the screen. Dark resistance means the resistance of a device, measured by the device when the sensor is placed in the dark. So when the sensor is placed in the dark, the resistance of the device increases increases more in mega ohms. The value of the resistance will be in mega ohms. And when it is placed in the light, it will be some ohms, not in kilo or mega ohms. It's just in the value of ohms, like 100, 200 ohms. But if it is placed in the dark, it will be more than kilo ohms. And when the device is placed in the light, then the resistance decreases drastically. If constant voltage is applied to the device, and intensity of light is increased, and then the current starts increasing. You can see I mentioned a graph there on the screen. This graph shows the resistance versus illumination curve of LDR. These devices, these LDR devices are non-linear devices. Their sensitivity varies with lambda, wavelength of light incident on them. Some photocells might not at all respond to a certain range of wavelength based on the material used. Different cells have different spectral response curves. When the light incidents on the device, resistance varies. The change in resistance takes place while it takes 1 or more seconds for the resistance to rise back again to its initial value after removal of light. So in the next slide, see, in this slide I've shown the definition of resistance recovery rate, which I told earlier. When the light incidence on the device, change in resistance takes place while it takes seconds, more than 1 second, to gain its original value of resistance. This is called resistance recovery rate, this phenomenon. These LDR devices are less sensitive compared to photodiodes and phototransistors. As I told you, photocells, LDRs are also called as photocells. These are different from photodiodes and phototransistors. What's the difference? Okay, now let's take photodiode. It is a p-n junction semiconductor device that converts light to electricity. And while coming to LDR, our device, it is a passive device. There is no p-n junction in this device, and this also not converts light into electricity. This just changes the conductivity path for electricity. Depends on the light falls on it. Now there are different types of LDR sensors. There are two types based on the materials used. They are classified into intrinsic photoresistors and extrinsic photoresistors. I also told you LDR is also called as photoresistor. Now let's see what is intrinsic photoresistor. These sensors are made with pure semiconductors such as silicon, germanium. You all know they are best examples of semiconductors. in which electron gets excited from valence band to conduction band. As I told you earlier in the working principle, photoconductivity, the excitation. So here the electron gets excited from valence band to conduction band when exposed to light, and number of carrier charges increases. And coming to extrinsic, this is also made of semiconductor materials, but with doped impurities. You all know now, which are called dopants. These create new energy band above valence band, which are filled with electrons. Hence, this reduces the band gap, and less energy is required for excitation. These are generally used for long wavelengths. Earlier, I mentioned a picture of a conduction band and valence band. If another band is created on the valence band, then the distance between conduction band and the newly created band is decreased, and it takes less time to reach the conduction band from newly created band, which means the excitation requires less time. Now coming to the construction of the sensor, and I also you can see on the screen the picture of LDR sensor and the circuit which we use this sensor. And coming to the construction, the structure consists of a light sensitive material which is deposited on an insulating substrate such as ceramic. This is mostly used material for making LDR sensors, and the material is deposited in zigzag structure pattern. You can see there is like a snake-like structure, which is zigzag structure pattern, in order to maintain the desired resistance. The zigzag area separates the metal deposited areas into two regions. Then the ohmic contacts are made on the other side of the zigzag area. You can see first on the picture there are contacts, metal contacts. I mentioned the material ceramic also. Then the resistance of these contacts should be as less as possible to make sure that the resistance mainly changes due to the effect of light only. For these metal contacts, generally we use the materials like cadmium sulfide and cadmium selenide, cadmium sulfonide, etc. The use of lead and cadmium is avoided as they are harmful to the environment. The size of the LDR sensor is not so big, it's very small. You can see the circuit there. It's circuit where we use LDR sensor. Yeah. Next we go to the applications. If we want to detect a light, we can use in many applications. We can create our own application, like if we needed to find if the door is opened or closed by using LDR sensor. So we can place a LDR sensor inside the door. We can choose the if the door is open, the sunlight from outside falls on the sensor, it detects and it tells us like the door is opened. When the door is closed, it will be dark, and it will also indicate the resistance value, some resistance value, so that which is different from the light falls on it, so we can tell the door is closed. Like that we can create our own applications and generally used applications. You know that this sensor is very low cost, and it's a simple structure. It is used when there is need to detect the absence and presence of the light. This LDR sensor used on street lamps. You can see on the highways, flyovers, there will be lights, right? They will automatically lit on when it's dark. There will be sensors in it. They will detect the resistance value, which means the light, it will be dark, then the resistance value is high, which means dark means it's evening, right? Then the lights all will lit up according to the resistance value. And with street lamps and light intensity meters, which are used on conveyor belts to count the number of packages or moving on the conveyor belt. You can see I mentioned the pictures. This is light intensity meter, and this is just a cartoon picture of street lamps. So this is a explanation, guys. LDR sensor. Hope you guys like it. I refer to a YouTube video to understand about this sensor, and you can also visit that many videos. So thank you guys, thanks for your patience to listen to my explanation.